In this video, we're going to pick up where we left off from last video and complete some harder examples involving solving trigonometric equations. So starting with our first example, let's just rewrite it to the side. We're solving 4 root 3 times sine of 3x, which equals 6. And we're solving for the x values between negative 90 degrees and 90 degrees. So the first thing we want to do is rearrange the equation to simplify it down a bit. So we're going to take the 4 root 3 to the other side, and we get sine of 3x is equal to, if we divide the 4 over, we get 6 over 4. And by dividing the root 3 over, we get 1 over root 3. Now notice here that the 6 over 4 can cancel out to 3 over 2. And the 1 over root 3 can be turned into root 3 on 3 by rationalizing the denominator. And we can do that by, if we rewrite our 1 over root 3, we can multiply and divide by the square root of 3. And we can see that we have root 3 times 1, which is root 3, and root 3 times root 3, which is root 3 squared. And the square roots cancel out, so we're left with 3. So we have 1 over root 3 turns into root 3 on 3. And so let's write that in. So we get root 3 divided by 3. And now notice that our 3's cancel out. So if we cross out the 3's, we're left with sine of 3x is equal to root 3 on 2. Now remember, whenever we have something associated with the x, we're going to make a dummy variable. So in this case, we're going to let our dummy variable theta equal to 3x. And now we're going to make that substitution back into our original equation, and we're going to get sine of 3x, which is now theta, equals the square root of 3 over 2. But now notice that our equation is in terms of theta. And so we got to change our domain in terms of theta, as it's still in terms of x between negative 90 and 90 degrees. So if we look at our dummy variable, we know that theta is 3 times x. And that means that the domain of theta is going to be 3 times the domain of x. So all we have to do to get our domain of theta is multiply our domain of x by 3. So we get negative 90 multiplied by 3 is going to give us negative 270 degrees. And positive 90 times 3 is going to give us 270 degrees. And so now we can solve for sine of theta. We can solve for the angles of theta that give us sine equal to root 3 on 2. So the next step is to draw the unit circle. The first thing to do after drawing the unit circle is always to draw in your domain. So our domain in this case is between negative 270 and 270 degrees. So if we start at 0 degrees on the positive x-axis and go clockwise around, we're going to get negative angles, and we're going to go to negative 270 degrees. So that will be this angle here. And then we're going to go all the way to 270 degrees. So if we start at 0 and then go anti-clockwise around, positive angles, we're going to go to 270 degrees, which is going to end up here. So what we're actually going to do is go from negative 270, this will be negative 180 now, negative 90, then we're at 0, and now we need to go back around to positive 90, positive 180, and then positive 270. So this is our domain here. Now looking at our equation, we're dealing with sine, so we're going to be looking at the y-axis, as sine is always read off the y-axis on the unit circle. And now we're going to write in our value of root 3 on 2. So root 3 on 2 on the y-axis will be a value, say, about there. And we're going to find our angles that represent this. So let's draw in these angles. So we're looking for angles in the first and second quadrant. Now we use the Masterly table to find our angle in the first quadrant, and then use the symmetry of the unit circle to find the other values of theta. So using our Masterly table, we're going to be solving for sine theta equals root 3 on 2. And so if we're dealing with sine, we're going to go along the sine row, and we're trying to find root 3 on 2. So the square root of 3 divided by 2 will be along this column, and that's going to give us pi on 3 radians, or 60 degrees. And because our domain is in degrees, we're going to keep our answers in degrees. So we're going to have theta is equal to 60 degrees, which is the value of this angle here. Now to find our angle in the second quadrant, we know that this angle here is 180 degrees. So we start at 180 and subtract 60 and we get 120 degrees. So our next angle is going to be 120 degrees. But notice here that our domain actually goes across this second quadrant twice, once in the negative direction and once in the positive direction. So we actually need to account for the negative case as well, because remember our domain goes to negative 270 degrees. So if we start at 0 and go to negative 180 degrees, we need to subtract another 60 degrees to get to this angle here. So we're at negative 180, take 60 is going to get us to negative 240 degrees. And so that gets us our final angle. So now we have successfully solved for our angles of theta, but remember we need to solve for our values of x. So we need to resubstitute our values for theta, which equal 3x. And now we can solve for x by dividing all these solutions by 3. So we get x is equal to 60 divided by 3, which is going to give us 20 degrees. 120 divided by 3, which is going to get us 40 degrees. And lastly, we get negative 240 divided by 3 is going to give us 80 degrees. So our three solutions for x, our three angles that satisfy our question, are going to be these angles here, 20, 40, and negative 80 degrees. So that concludes this example, and let's move on to another. For our next example, we want to solve for the angles of x between 0 and pi radians that satisfy the expression above. So let's write down this expression. So we have 2 cos squared x, take cos x, take 1 is equal to 0. Now if you look here, we have a cos squared, a cos, and a constant equal to 0. And this awfully looks like a quadratic equation. So what we're going to do is we're going to make a dummy variable, y. So we're going to let y equal cos of x and see if we get any interesting results. So let's resubstitute this value in. And so we get 2 cos squared, which is going to change to y squared, take cos of x, which is just y, take 1 equals to 0. And notice here that we do have a quadratic equation in which we can factorize. So let's do that now. Let's factorize this quadratic equation and we get y take 1. And 2y plus 1 will work in this case. Now we're not going to go over the details on how to factorize quadratic equations, as this is already discussed in a previous playlist. So now we can use the null factor law to solve for our values of y. And so we're going to have one equation, y take 1 equals 0. And by solving for y, we get y equals to 1. And resubstituting our value for y, we get cos of x equals 1 as one of our solutions. And now we can have our second equation, 2y plus 1 equals 0. And by solving for y, we get y equals subtracting the 1 to the other side and dividing by 2. We get negative 1, and dividing by 2, we get negative 1 over 2. And substituting our value for y, we get another equation, cos of x equals negative a half. And so now we have two expressions where we can use the unit circle to solve for our solutions of x. So now that we've drawn the unit circle, we can fill in our domain. And our domain is between 0 and pi radians. So starting on the positive x-axis at 0 radians, we can go around anti-clockwise, halfway around the unit circle to get to pi radians. And because both of our expressions are in terms of cosine, we're going to be dealing with the x-axis. So let's label the x-axis in. And let's write in our values. So we're going to have a value of 1 on the x-axis and negative a half. So our value of 1 will be along the circumference of the unit circle on the x-axis. And a value of a half will be starting at 0 on the x-axis and going halfway left between the origin and our circumference. So this will be negative a half here. And let's draw some dotted lines to mark in our angles. And now let's label our angles in. Now let's consider this angle here first, and we could use the Masterly table to solve for what the angle is, but it's quite obvious as we're on the positive x-axis. and this is going to give an angle of 0 degrees or 0 radians. Now, as our domain is in terms of radians, we're going to keep our solution in radians. So we got one solution of x being 0 radians. Now, considering our angle in the second quadrant, this occurs when we have a value of -half on the x-axis. And so what we're going to do is we need to find the corresponding angle in the first quadrant and then use the symmetry of the unit circle to find the value in the second quadrant. So flipping this over to the other side, we're going to have when x is +1/2, which is going to occur halfway between the origin and our circumference, which is going to be this angle here. And let's draw a dotted line up and let's write in this angle. So now we want to solve for our angle here, which makes cos equal to 1/2. So we're solving for the equation cos of theta equals 1/2. And now we can use the Masterly table. So we're dealing with cos. So we're going to go along the cos row and we're going to be looking for 1/2. So we're going to be at the square root of 1 divided by 2. So this column is going to give us our angle that will make cos 1/2. And this occurs at pi and 3 radians. So theta will be pi on 3 radians. So this angle here is pi on 3 radians. And now we can use the symmetry of the unit circle to find our angle in the corresponding second quadrant. And so if we're at pi radians or 3 pi on 3, so let's just write this in, 3 pi on 3 radians, and we subtract pi on 3 radians, we'll be at this angle here. So we just need to complete the equation, 3 pi on 3, subtract pi on 3, which is going to give us 2 pi on 3 radians. Now consider our angle in the third quadrant and notice that it does not fit into our domain between 0 and pi radians as it is not inside this red arc here. And so our angle in the third quadrant will not be a solution for x. And this means that our only solutions for x are going to be 0 radians, which is from this angle here, and 2 pi on 3 radians, which is from our angle in the second quadrant. And that concludes this example, and let's move on to one final example. For our final example, we want to solve for the values of x that are between 0 and 2 pi radians that satisfy the following expression. So let's rewrite this expression. We have cos of x plus pi on 4 is equal to 1 over root 2. And remember, whenever we have something associated with the x, we're going to make a dummy variable. So we're going to let some dummy variable theta equal to this value here, x plus pi on 4. And so now, resubstituting this into our original equation, we get cos of x plus pi on 4, which is now theta. Cos of theta is equal to 1 over root 2. And now we're going to rationalize the denominator. So we're going to times by root 2 and divide by root 2. And this is going to equal root 2 times 1, which is root 2, divided by root 2 times root 2, which is root 2 squared, and the square roots cancel out, and we're left with just 2. So now we're solving for cos theta is equal to root 2 over 2. And now realize that our variable is in terms of theta now. And so we're going to change our domain in terms of theta. And we can do this by considering our dummy variable expression. And we have theta is equal to x plus pi on 4. And this means that the domain of theta must equal the domain of x plus pi on 4. So if we start with our x being greater and equal to 0, then our domain of theta must be greater and equal to 0 plus pi on 4, which is going to be pi on 4. And it's going to be smaller than or equal to 2 pi plus pi on 4, which is going to be 2 pi can be rewritten as 8 pi on 4 plus pi on 4, which is going to give us 9 pi on 4. So we get 9 pi on 4. And now you can see that we're in the position where we have simplified our problem and we can draw the unit circle. So let's rub this out to leave some room, and now we're going to draw the unit circle. The first step after drawing the unit circle is always to fill in your domain. And our domain in this question is between pi on 4 and 9 pi on 4 radians. So first we're going to fill in an angle of pi on 4 radians, which is going to be about here. Something like this. And we're going to draw in our domain. So our domain starts at pi on 4, this angle here. And we're going to go all the way around the unit circle. All the way around. And remember, 9 pi on 4 was just 2 pi plus pi on 4. So we're going to go to 2 pi, which is this angle here, and add another pi on 4, and then we're going to be back where we started. So this is our domain here. Now we can consider our expression and realize that we're dealing with cosine, so we're going to be looking off the x-axis on the unit circle. And now the next step would usually be to mark in our root 2 on 2 value on the x-axis, but what we're going to do first is going to use our masterly table to find the angle in the first quadrant. And you're going to see why this is going to be helpful in a minute. So if we find our angle in the first quadrant, we're going to be finding cos of theta equal to root 2 on 2. So we're going to go along the cos row and look for root 2 on 2. And this is going to occur at root 2 on 2 at this column here, which is going to be at pi on 4 radians. And so notice that one of our solutions for theta in the first quadrant is going to be pi on 4 radians, which is in fact our angle in our domain here. And so that means that our x coordinate, root 2 on 2, is going to be this value here. So the reason why I found the angle in the first quadrant before marking in my coordinate on the x-axis was in case that our angle was going to be this domain angle here, pi on 4, which in this case it is. And so we can extend out and find our angle in the fourth quadrant. And so let's mark this angle in now. We can find this angle in the fourth quadrant by considering the symmetry of the unit circle. So if we start at 2 pi, which can be rewritten as 8 pi on 4. So we start at 8 pi on 4 and subtract pi on 4, we'll get to our desired angle, which is going to be 8 pi on 4 subtract pi on 4, which is 7 pi on 4. And now I want you to consider the angle in our first quadrant one more time. And notice that our domain starts at this angle and wraps around and also ends at this angle. And so this angle is actually accounted for twice. And so we've actually missed one angle, which is going to be 9 pi on 4 radians at this very end point here of our domain. So we have 9 pi on 4 radians as our final solution of theta. And now that we found our solutions for theta, we can resubstitute and solve for x. So we know that theta is equal to x plus pi on 4. And we can take the pi on 4 to the other side to solve for x. So we get x equals pi on 4 take pi on 4, which is going to be 0 radians. And then we get 7 pi on 4 take pi on 4, which is going to be 6 pi on 4. So we get 6 pi on 4 radians, which can be simplified into 3 pi on 2. So let's write that in. 3 pi on 2. And we have 9 pi on 4 take pi on 4, which is going to be 8 pi on 4 radians. And 8 pi on 4 can also be simplified into 2 pi. And so these are going to be our 3 solutions for x that satisfy our equation above. And that's going to conclude this video. And in the next video, we're going to do some review questions that cover the concepts throughout the whole playlist.